Pryor, you listen to me. I don't care what you do once this thing's over with. You can lay down and die and rot in the street.
For years, when people pictured Florida's war on invasive snakes, they pictured burly men in rubber boots wrestling 12-foot Burmese pythons out of the sawgrass on the evening news. It made for great television, and it made Florida look like it finally had a plan. Hunters were paid by the foot. Contests were held every summer. Governors posed for photos holding dead snakes as long as canoes. But while all of that theater played out in front of cameras, something much smaller, much stranger, and far more consequential had already slipped into the swamp almost unnoticed, riding inside the very snakes everyone was trying to kill. And when biologists finally understood what it was doing, the story stopped being about hunters and cameras altogether. It became about something almost too strange to believe. A living creature, smaller than a fingernail clipping, quietly working its way through the lungs of Florida's snakes, killing them from the inside, and spreading faster than any bounty program could ever keep up with. To understand how something this small became this big of a problem, you have to go back to where the whole python crisis started in the first place. Burmese pythons are not native to Florida. They come from the humid forests and river valleys of Southeast Asia, where they've lived alongside their natural predators, parasites, and diseases for millions of years, developing a kind of biological armor built from constant exposure. In the 1970s and 80s, that changed. Burmese pythons became wildly popular in the American exotic pet trade. Hatchlings that fit in your hand grew, within a few short years, into muscular predators 18 feet long and heavier than a grown man. Plenty of owners realized, often the hard way, that a snake that size does not belong in a suburban home. Some of those snakes escaped. Many more were deliberately released into the canals and marshes of South Florida once they became too much to handle. Then, in August of 1992, Hurricane Andrew tore through Miami with catastrophic force, flattening a python breeding facility and setting hundreds of captive bred snakes loose into a landscape that, as it turned out, was almost perfectly suited to them. Warm, wet, full of prey, and completely lacking the natural checks that had kept python populations in balance back home. Wildlife officials at the time had no real playbook for a problem like this. Florida had dealt with invasive species before, iguanas eating through gardens, walking catfish crossing roads, even feral hogs tearing up farmland, but nothing on the scale of an apex predator capable of 18 feet in length and 200 pounds establishing a permanent breeding population inside one of the most ecologically important wetlands in North America. Early sightings in the 1980s were treated as curiosities, isolated escapees that would surely die off on their own once winter came. Florida doesn't really have hard winters, though, and pythons, it turned out, were remarkably good at surviving even the occasional cold snap by burrowing into gopher tortoise holes or thick vegetation until temperatures rose again. By the time anyone in a position of authority took the threat seriously, the snakes already had a multi-decade head start, breeding largely unchecked across a landscape almost perfectly designed to hide them. For the next 3 decades, the python population exploded across the Everglades. Estimates now suggest tens of thousands of Burmese pythons are living across more than 1,000 square miles of southern Florida, from the tip of the peninsula up through Everglades National Park and into the sprawling wetlands beyond. And these are not shy, harmless newcomers. A single female python can lay dozens of eggs at once, and an adult can swallow prey as large as a full-grown deer or an alligator. Studies tracking marsh rabbits released into python territory found that within less than a year, pythons were responsible for over 3/4 of the rabbit deaths recorded. Populations of raccoons, opossums, bobcats, and foxes have collapsed by more than 90% in some of the hardest-hit areas. The endangered Florida panther, already clinging to survival, has lost a significant portion of its traditional prey base to a snake that didn't even exist in this ecosystem 50 years ago. The scale of that predation is difficult to overstate, because pythons are ambush hunters capable of consuming prey far larger than their own head width, thanks to a jaw structure that essentially unhinges and stretches around a meal. Biologists have found the remains of full-grown white-tailed deer inside a single snake's stomach during necropsies. One captured python was found to have consumed a deer weighing close to its own body weight, an almost unbelievable feat that underscored just how little native wildlife stood a chance once a python decided to hunt. Camera trap surveys conducted in areas with the heaviest python density recorded a staggering collapse in mammal sightings compared to areas where pythons had not yet spread, with some species essentially vanishing from the data entirely. It became one of the starkest, best documented examples in modern conservation science of what a single invasive predator can do to an ecosystem that never evolved defenses against it. Florida's response was loud, expensive, and very public. The Florida Fish and Wildlife Conservation Commission and the South Florida Water Management District built an entire python elimination program, paying trained hunters an hourly wage plus bonuses for every foot of snake they brought in. Biologists developed an even more clever trick, fitting male pythons with radio transmitters and releasing them back into the wild as so-called scout snakes, letting the males lead researchers straight to breeding females during mating season, when a single capture could prevent thousands of future hatchlings. Every summer, the Florida Python Challenge draws hunters from across the country for a chance at cash prizes and bragging rights. By some counts, more than 22,000 pythons have been removed from Florida since the year 2000. It's an impressive number, and headline writers loved it. But here's the part almost nobody was talking about at the time: the detail buried in dissection reports and university lab notes rather than press releases. Every single one of those tens of thousands of pythons that slithered into the Everglades over the decades brought a passenger with it. Not a companion species. Not a predator riding on its back. Something living inside its lungs. The discovery itself happened almost by accident, the way a lot of the biggest scientific findings do. Researchers performing routine necropsies on captured pythons, cutting the animals open to study their stomach contents and confirm what they'd been eating, kept noticing something odd inside the lungs. Pale, segmented, worm-like organisms clustered in the respiratory tissue, present in python after python, far too consistently to be some kind of one-off fluke. At first, it barely registered as newsworthy. Wild animals carry parasites constantly, and a parasite living quietly inside an invasive species wasn't exactly a shocking headline. It was only when field biologists started finding the same organism inside native Florida snakes, species that had no business sharing a parasite with an animal from the other side of the world, that alarm bells started going off in university labs across the state. The parasite has a name most people have never heard: Raelietella orientalis. Researchers who study it often just call it the snake lungworm, though technically it isn't a worm at all. It belongs to a bizarre group of organisms called pentastomes, sometimes nicknamed tongue worms, which occupy their own strange branch of the animal family tree, distantly related to crustaceans rather than true worms. In its native range across Asia, Raelietella orientalis live quietly inside the lungs of pythons and rarely causes serious harm, the same way a common cold rarely kills a healthy adult. Burmese pythons evolved alongside this parasite for so long that their bodies simply tolerate it. A 14-foot python has more than enough lung capacity to host the pale, thread-like parasite, often described by researchers as looking something like a bean sprout, without much noticeable effect. But evolution didn't prepare Florida's native snakes for this at all. When infected pythons began sharing swampland, water, and prey animals with Florida's rat snakes, cottonmouths, and rattlesnakes, the parasite jumped hosts. And what was a manageable house guest inside a python became a death sentence inside almost anything smaller. A python's respiratory system is built on a massive scale, with a long trachea and enormous lung capacity. Native Florida snakes are proportionally tiny by comparison, some species barely reaching 2 feet in length. When the same parasite that comfortably occupies a fraction of a python's lung takes up residence inside a 2-foot pygmy rattlesnake, there simply isn't room. Biologists studying infected native snakes have described lungs so packed with the parasite that the animal essentially suffocates from within, sometimes with the pale, wriggling parasites visibly emerging from the snake's mouth in its final days. Wildlife photographers and hikers who stumbled across the carcasses had no idea what they were looking at. Researchers who did understand were horrified. What makes this even harder to control than the pythons themselves is the way the parasite spreads. It doesn't pass directly from snake to snake through a bite or contact. Instead, it has a life cycle that reads almost like something out of a horror movie, cycling through infected feces, then through insects and small amphibians that pick up parasite eggs while feeding on contaminated ground, and finally into snakes that eat those infected insects or amphibians as prey. Every link in that chain gives the parasite a new opportunity to spread further into the ecosystem, and every native predator that eats a contaminated meal becomes a potential new host. Unlike a python, which you can spot, chase, and physically remove from the wild, this threat is invisible until a snake is already dying or dead. There is no bounty program for a parasite. There is no cash prize for finding one. You cannot wrestle it out of the grass on camera. For years, when concerned herpetologists first raised alarms about a parasite spreading from invasive pythons into native wildlife, a lot of people simply shrugged it off. Compared to a giant constrictor capable of swallowing a deer whole, a microscopic organism living in a snake's lungs seemed almost quaint. Some in wildlife management circles reportedly treated the early warnings as a secondary concern at best, a footnote to the real fight against the pythons themselves. Snakes get parasites all the time. The thinking went. Nature handles it. Why divert limited funding and research staff to chase something you can't even see with a naked eye when there are 18-foot predators eating the panther's last rabbits? It's the kind of dismissiveness that, in hindsight, looks almost embarrassing, because what researchers eventually documented turned out to be one of the most efficient, most quietly devastating invasive species stories in modern American ecology. Researchers studying the outbreak have described the process of finding an infected snake in unmistakable, almost cinematic terms. A dying snake, weakened and struggling to breathe, sometimes found along a roadside or hiking trail, with pale parasites visibly protruding from its mouth as its body tries and fails to expel an infection it has no way of fighting off. For scientists trained to see this kind of thing as data points in a spreadsheet, the visceral reality of it was still jarring the first several times they encountered it in the field. One researcher working in a university lab described comparing preserved specimens of the parasite side by side with samples pulled from a dead rattlesnake, trying to understand just how thoroughly the infection had taken hold before the animal succumbed. That kind of hands-on, unglamorous lab work, far removed from the cameras and bounty programs that made the python hunt famous, is where the real fight against this crisis is actually happening. By the time biologists at the University of Florida and the University of Central Florida began seriously tracking the parasite spread, it had already jumped into more than a dozen native snake species. What had started as an isolated curiosity in a handful of dissected pythons near the southern tip of the state had, within a matter of years, expanded its range dramatically. Mapping efforts published as recently as 2025 showed the parasite's presence extending well beyond South Florida, moving north along waterways and wildlife corridors far faster than anyone initially expected. Scientists established a public reporting network called the Snake Lungworm Alliance and Monitoring Project, essentially asking hikers, anglers, and everyday Floridians to report any dead snake they find showing signs of infection, because researchers simply do not have the staff to survey the sheer size of the affected territory on their own. It's a crowdsourced surveillance system for a threat that outpaces every conventional tool wildlife agencies have. And here is where the story stops being just a Florida curiosity and starts becoming genuinely unsettling. Pentostomes as a group are not exclusively a snake problem. Related species in this same bizarre lineage have, in rare cases, infected humans, usually through contact with contaminated meat or water in tropical regions of the world. Doctors have documented rare, alarming cases elsewhere in the world involving pentostome parasites migrating into unusual places in the human body, cases so strange they've made international headlines on their own. Researchers studying Florida's outbreak have been quick to stress that the risk of Railiatella orientalis specifically infecting a person is considered very low, and there is no confirmed case of it happening. But they've also been candid about one thing you might not want to hear if you're a fan of Florida's increasingly popular python meat dishes, the curries and fried python recipes that some chefs have promoted as a creative way to put the invasive species to use. Scientists studying the parasite have specifically warned against eating undercooked python meat, precisely because of parasites like this one living inside the animal's tissue. What was pitched as a clever culinary solution to an ecological problem turns out to carry its own small asterisk of risk, courtesy of the very parasite most people had never heard of. The deeper you look into this story, the more it starts to feel like a lesson in how invasive species problems rarely stay contained to the thing everyone is watching. Florida spent years and a tremendous amount of money and media attention focused on the visible enemy, giant, photogenic, headline-friendly pythons. Meanwhile, the parasite those pythons carried worked its way through the ecosystem largely unnoticed, exploiting every one of Florida's 44 native snake species as a potential new host, none of which had any evolutionary defense against it. Some of those native species, like certain rattlesnake populations, were already under pressure from habitat loss and a separate, unrelated snake fungal disease. Layering a lethal, fast-spreading lung parasite on top of those existing stresses is the kind of compounding ecological blow that conservation biologists genuinely dread, because it doesn't just threaten one species in isolation, it threatens the resilience of the entire native snake community at once, at a moment when many of those species were already struggling to hold their ground. It's worth being clear about one thing, because the dramatic framing you may have heard elsewhere can blur an important distinction. Florida did not intentionally release this parasite as some kind of deliberate biological weapon against its own snake population, and no wildlife agency ever announced a program to unleash thousands of parasites into the wild on purpose. What actually happened is quieter and, in some ways, more troubling than that. An entire hidden threat rode into the state for free, tucked inside a much larger and more visible invasive species that Florida spent 30 years and millions of dollars trying to remove. The pythons were the headline. The parasite was the fine print nobody read until it was already spreading across the state. And once biologists finally connected the dots, piecing together dissection reports, field surveys, and a rapidly growing map of infected wildlife, the picture that emerged was almost stranger than fiction. A microscopic hitchhiker, smaller than a AAA battery, potentially reshaping the future of Florida's native reptile populations more thoroughly than the giant snake everyone had been chasing on camera for a decade. So where does that leave things today? Researchers are still racing to understand exactly how far the parasite has spread, which native species are most vulnerable, and whether there's any realistic way to slow its advance once it's established in a wild population. Unlike a python, you cannot offer a bounty for a lungworm. There is no way to trap it, no